Cool. Let's get started.
Cool. So hello, everyone. Thank you so much for joining us. I see so many of you have joined from different parts of the world, different times. So thank you so much. I'll introduce myself real quick. My name is Samia, and I'm a software engineer at Microsoft. I work on building tools for Azure customers in the GitOps and cloud native space. I'm passionate about open source, GitOps, a lot of front-end related projects. So, I'm very excited for this talk about microservices because this would probably apply to so many of my projects. So let me jump in and introduce Tracy. Tracy is an expert in configuration management and pipeline lifecycle practices with a focus on microservices and cloud native architecture. Currently, she serves as a board member of the CDF, which is Continuous Delivery Foundation, and the executive director of the Ortelius open source project for microservice management. In addition, Tracy is a recognized evangelist in microservices and continuous delivery pipelines. She is the Continuous Delivery Foundation interactive landscape creator, a blog contributor for the CDF, recognized by Tech Beacon as one of the top 100 DevOps visionaries. She speaks at many DevOps events such as CNCF's KubeCon and CloudBee's DevOps World. Tracy is also a DevOps Institute ambassador and speaks at AWS Marketplace webinar educational events. Today, Tracy is going to talk about taming microservices through an evolved pipeline. So without further ado, I'll hand it over to Tracy.
Thank you so much. I appreciate that introduction. So yes, we're going to really talk about the disruption we're going to be seeing very soon. Some of you may have already seen that disruption in our what we like to call our pipeline. And I've got to wake up my, okay. So microservices really do interrupt. I say DevOps as usual, but it's actually all software development as usual. They are a super critical part of our cloud native journey. Without them, I don't believe that we could achieve what I like to call the last mile of Agile. We always say that we've achieved Agile, but to be quite honest, if you look at what we've done through the pipeline, our builds and our deployments have always been monolithic. And microservices really is that last mile of Agile where we can do things in a fully incremental way. But the problem is that they are disrupting how we develop software, how we design it, and how we release it. And really at the core of this disruption is the shift away from monolithic software practices and moving into what I like to call a component-driven microservice architecture, where collaboration across siloed teams are going to be super important, methods for sharing common services. All these things are going to need to be part of our DevOps pipeline. So this discussion, we're going to cover primarily the organizational changes and what I like to say, where you probably should be spending your time and money. Thank you again for that introduction. I probably should have thrown the screen up, but if you would like to chat with me, you can find me on LinkedIn, Tracy-Ragan-OMS. Shoot me a message if you want to chat. I'm happy to send you my calendar so you can schedule some time on my calendar. And I would love to talk to you about the open source community that we're working on, and we'll cover a little bit about that. But let's just get to the kind of the meat of the matter. I think all of you, since this is pretty much a cloud native, group, know about this and what's happening in terms of the cloud native environment and why we're moving to microservices. But we have to really understand why microservices are being adopted. And if you're in an organization that has decided they don't want to adopt microservices, you need to understand what you need to tell them to say, yes, this is the way to go. But the kind of the usual suspects is faster time to market, adapting to market changes, all of the things that we talked about in Agile practices is why we need to move to a microservice architecture. Other things like the underlying SaaS technologies, everybody's got a SaaS now. Our open source project can be actually installed as a SaaS. Everybody's talking about the need for fault tolerance. Security is a huge, huge topic right now. And to be quite honest, microservices are more secure than a monolithic, and the ability to auto scale. And we sort of learned that in the COVID world. So everybody's sort of agreeing that, management wants to decrease the time to market. End users want data, they want it now. They want smarter apps. Developers want to develop in smaller increments, in real smaller increments, not smaller increments in code and monolithic builds and releases. And operations, they really need that fault tolerance and the auto scaling in order to support everything we do. Just imagine what Netflix goes through when they've got a smash hit out there and everybody's waiting to watch that next episode. They're supporting people around the world to do so. They've got to be super agile, super fault tolerant, and auto scaling. And yes, I wouldn't be right if we didn't talk about COVID and what COVID did to the cloud native community. Over the last year, I have spoken to so many SREs who are big time stressed out. We sort of rushed in and people started taking their monolithic and moving it over to a container so that they could auto scale the entire container. They were doing everything they could to be able to support the demand that they required with this new cultural shift that we've gone through, from kids being at school online and parents working online and everybody being at home. It did change the way we think about the world. And according to this article by Michelle Grover, she says that 96% of UK enterprise decision makers believe that the pandemic sped up their digital transformation by at least 6%. It's a big deal. So that's about 5.3 years on average. And according to the Linux Foundation, these new markets are really kind of being pushed out. Now, if you've never read anything from Tyler Jewell, I highly recommend you follow him. He's great in terms of this kinds of research. He sees there's two trends that are happening. One is the emergence of the service catalog, and we're going to talk a lot about that and how that fits into DevOps, and also the convergence of continuous delivery and GitOps and what he calls experimentation vendors. And the Linux Foundation, in their survey last year, they said that the use of containers is up about 92% of their people they spoke or surveyed say that they're using containers, but that doesn't necessarily mean they're using microservices. But 83% claim that they're using Kubernetes in production, which is a sign that microservices is really next. So just so we understand sort of the growth and this transformation path, first we went to cloud and VM really taught us we could dump physical servers. Yay! That was a really good idea. That was the best idea anybody ever had. Then we went to cloud and containers, and Docker taught us to isolate these monolithic applications in containers, so we didn't have to worry about a certain version of an operating system, for example. That brought us to Kubernetes and the ability to orchestrate these containers with the self-healing and auto-scaling that the operations side of the house need. That's pretty much all sorted out. So now we're in round 4, which is really building out microservices and evolving Kubernetes and containers to a point where we are really going to achieve Agile. That last mile of Agile where we have small independent functions being pushed out all day long. So here we are breaking up the monolith, and breaking up is really hard to do. It is, especially since we haven't looked at our applications like this really in the past. We've had some experiences with it. We have seen, service-oriented architecture and SOA was very important and based on APIs, but we really still didn't see it as a component-driven solution. We were still looking at building jars and mores, and the compile process is where most of this stuff was done. So now, when you're talking about breaking up the monolith, your business agility is achieved because you have this high level of reuse across application teams of these small bounded context services, and they are key to this final step in this transformation, and will probably launch us into some really interesting futures when it comes to sharing code globally, which is why security becomes important. But moving to microservices, as I said, companies have struggled with it. There are some natural complexities in microservices that we have to address in the DevOps pipeline. This article came out early in 2019 by a woman by the name of Alexandria Noonan. She works at a company called Segment. What she said when they went to move to microservices, she says, well, what happened is we would release an update to a library, and then one service would use the new service. And now all of a sudden, all these services were using older versions, and we had to keep track of which services were using which version of the library. That's a typical standard configuration management problem. And as Randy Hefner from Forrester has been talking about quite a long time, he says that microservice development falls apart without a coherent, disciplined, managed approach. So we have to think about it in the way as we're taking our static application and we're breaking it up into smaller puzzle pieces. What does that mean for not just developing it, but pushing it through the life cycle? What does it mean for our DevOps pipeline? So let's just break it down. I'm going to break down the pipeline in a way that I'm hoping it will stimulate your thought so you can start coming to these conclusions on your own. So certainly, if there's a question or if there's something that you want to add to this conversation, please speak up. This is a meetup. This is not a webinar. We're all in a virtual room together. So you can, raise your hand or just say, hey, Tracy, while I'm going through this. So now we all know this. We all have met this, or we have served as a build manager. I served as a build manager for years and years and years, so I know this too well. But a build manager really does some unsung, they're heroes, they're unsung heroes, and they oftentimes are the central point of all of what we would call configuration management. And I'm going to shift that word now to supply chain management, because it's the build manager who is carefully, they write a build script, and that build script is what determines what is going to go into the compile process and then the package. If you happen to have attended the KubeCon supply chain conference, I think Trevor Resin, I think his name was on that. There's some stuff on YouTube that you can see from that conference, but they talked about how the SolarWinds problem occurred. And it was as simple as in their package processing, they probably did a star.star and a nefarious DLL got stuck in there, got put in their package, and it simply waited for 2 weeks until it did something, and it was dormant for that 2 weeks, and then it went and did its bad job. Simple. It was a simple way to break in, and it happened at this build step, and probably through a build script, something that was very imperative. The build managers use version control and artifact repositories to kind of pull this stuff together. And what they do is they create an application binary and give it a version, oftentimes give it a version number. So now we have everything tied up in one nice big fat binary. We can create a bill of material. If you're good at what you're doing as a build manager, you're going to create a BOM report. And then you could create a difference report. And that's what gives us our North Star. So let's say we want to know the difference between two application releases. We can check a BOM report and do a diff between two difference reports, and we can see the difference of what we just changed. So these are critical pieces, and we still need them, but now they're no longer there. And why are they no longer there is because we have things that we're doing things a little different. Now we take a microservice developer, they're going to create their container. In their build step, they may use something like an artifactory. They may pull in something that does some sort of scanning. Then they register it to the container. And once it's registered to the container, it's ready to go. That's a release candidate. And that's going to get pushed across the dev, test, and prod environments. So what happened to our BOM report? What happened to our application version? And what happened to our difference reports? We don't have those anymore. And that is really why people, I believe, think that microservices are complex, because the tools that we're used to using in the past no longer fit in this architecture, and they don't need to. We need to adapt ourselves. We have to evolve as practitioners to support this new way of developing software. So most importantly is think about it this way. The monolithic step of the link is going to be replaced with APIs. Now, if you just digest that for a minute and you think about the rest of the pipeline, you'll see how different it is. We don't have the same kind of check in your code, do a 10-minute quiet period. When the quiet period is done and nobody's checked anything else in, we're going to compile our binaries. Then we're going to push our binaries out to a place that we can test them. The developers do their unit testing, and then we push it to the test workflow through our CD process, and the testing team does their work, and now we push it off to production. That goes away. That doesn't even, the thought of that shouldn't even exist anymore. Those steps still have to be done, but they have to be done different. And as we always say, the more things change, the more things stay the same. But there is a change. There is a big, we have to really see how we can really redo this.
Tracy, could I just interrupt you real quick? There is a question, what is integrated transformation path in the Q&A box here?
Let me look at the Q&A box. What is integrated transformation path? Well, you know, I don't know what that is because I've never heard of that term. Integrated transformation path. It's not, I'm not sure what that means. So I apologize. I've not heard that term before, but I'm sure somebody's using it and it probably means a lot. And potentially it could be some of the same things I'm going to be talking about. After this presentation, we could talk about that, what I think it might be, but I'm not going to go there right now. Okay, so the results of microservices is, first of all, I hear a lot of people say they feel like they're flying blind. They have no understanding of a microservices blast radius, who it's going to impact. A lot of SREs tell me, well, if we have a new microservice, we just deploy it out and everybody gets it. This whole idea of canary releases or rolling release goes away. As I said, there's no application version, there's no BOM or difference reports, there's lack of visibility, kind of creates bottlenecks. And then we start getting things like microservice drift and sprawl. And there's an increase in staffing to try to maintain these environments. And ultimately, if we're not successful at this, we're really never going to achieve the business agility that's driving us to do better. I don't know why my keyboard doesn't work. Okay, so let's just talk about some of the common problems and why people say this is a confusing or complex environment. First of all, drift and sprawl can be an issue. This is how I see most companies rolling out microservices. It is monolithic. It's a monolithic microservice implementation, in my opinion. Because in this case, the online store company they have 3 websites. They have candy, clothing, and a toy store website that they're managing. And each cluster gets all of the microservices that they need. They have the front end for each has their own front end, but they're each consuming the cart service, the shipping, and the payment service. Now, in this case, this clothing store CD pipeline kicked off. They pulled in a new version of the shipping service. So now we have drift between those clusters. This is oftentimes how I'm seeing the cluster architecture being implemented, whereby it looks very much like when we used to have our own servers. So in this case, everybody has their own server. Now, we could also increase this to say the candy store, clothing store, and toy store each have their own set of dev, test, and prod clusters. So we're gonna increase this by quite a bit by having them all broken out. So sprawl is drift is when a version is out of sync between clusters. Sprawl is if every single one of these websites wrote their own payment service. In this case, in my example, I show that they use the same one. But how do they know a shipping or payment service is actually out there? That becomes the question. If you don't know a service exists, somebody's already written a bounded context service that will serve your purpose, you're likely to build another one yourself. And that is what I call sprawl, because instead of being able to implement somebody's bounded context service, you wrote your own. Now you've got 2 or 3 of your own, and everybody does that. So it's hard to tell, if you're working for an enterprise and we're all in the same building, let's say, for example, and you're on the 8th floor, you don't know what somebody on the 4th floor just wrote. So again, this is part of the reasons why people say microservices are complex, but they don't necessarily need to be. We just need to evolve ourselves. Now, this is what we really want to get to. You know, if you're talking about being in an enterprise where you do have quite a bit of, you want more low code, you want more sharing, you want to minimize the amount of clusters that you have as well. And tools like Service Mesh, you know, Istio for routing, they're all intended to build these cleaner, more organized environments. So in this case, we have a financial service cluster, and they have a credit card namespace, they have an online banking namespace, and they have a merchant services namespace. They have shared services that they use. They use the customer info commonly, they use the reconciliation, and they use the fraud detection. Now, this is not unlike a compile process. If you think about how we might have compiled this, we would have taken the credit card, we would have taken the customer info and the reconciliation, the fraud detection, and we would have pulled it all into one big binary. Now that one big binary is in our cluster. So what we're trying to get to is an architecture that takes advantage of these shared services or these namespaces so that we can start sharing services that are common. Think about any of the security ones, like a login routine. A login routine, you probably want everybody using the same one, because if you need to change it, you change it in one place and everybody uses it. Now, this solves the drift, but it doesn't necessarily solve the sprawl. Okay, so let's talk about ways we need to change the pipeline. And before I go on, I'm just going to cruise the chat, or if there's any questions that anybody wants to bring up, just let me know. I'll wait just a second here while I ponder the other question. Okay, so hopefully these will be controversial and you will be thinking about it and saying, Tracy, you're crazy. I'm happy that you do that. So a couple of ways that we need to start thinking about our pipeline and how we need to manage it. Number one, we're going to talk a little bit about why version control will be less important and possibly used differently. We're going to talk too about the number of DevOps pipelines and how that's going to increase pretty substantially. We're going to talk about organization and why domain-driven design is something all of you should start learning. And we're going to talk about component-driven releases to support these independently deployed microservices. And I'm going to talk a little bit about supply chain management and maintaining SLOs. All right. Okay, let's talk about version control. We know that version control has been an essential part of our DevOps process. It has been absolutely key to what we do today. Everything we do pretty much is based on a commit. We are now DevOps by commit, to be quite honest. But in the world of microservices, you probably will have a lot less branching and merging. Now, that may not be the case for GitOps, and I can speak to that. But in just traditional source code management, we would have pieces of code that would be, literally 1,000 lines long, and oftentimes you had 2 developers working on the same piece of code, which is meaning the reason why we need to do branching and merging. We also would keep track of different releases, different monolithic releases based on those branches. Well, code's going to be smaller, and we're not going to be thinking about applications in terms of a full branch. So think of a Python script of 300 lines of code. How many times is that going to be branched and merged? I don't think that's going to happen as often anymore. And then the check-in and build practice is going to shift to just creating these smaller container images, not these monolithic compiles like we already spoke about. So while we'll still have version control, because we need a place to be able to manage and centralize all of our assets of the company, of the enterprise, we still are not going to be using it in the same way as we have in the past, because our code looks different. Now, number 2, this is spending time on really looking and improving your CD pipeline is going to be critical, because if you have every microservice and every microservice is independently deployed, that means potentially that every microservice should have its own its own workflow. So instead of having the hundreds of workflows you have now to manage the different versions of your applications, you will have thousands potentially, which means we have to really start reevaluating how we're doing the CD pipeline. We have always done very imperative pipelines. Everybody defines their own pipeline workflow through some kind of a file, and that's what the workflow builds on. That's how it executes. But maybe we need to be more declarative now. Now, there's some tools out there that are moving to more of an event-based pipeline. I add Jenkins X because Jenkins X is more templated, but Kepton and Tekton both are really more event-based CD tools. Tekton has become a big part of the open source security foundation now, as well as the CD Foundation, because they're looking at ways to use what we call chains, which actually tracks the who executed workflows in what order. It's security around your CD pipelines. And tools like Kepton really changed the way we think about our pipeline process. So think about this. Think about having an event like a listener or a broadcaster. It's broadcasting and listening. And you define, as a development team, you define the tools that you want to use. Now, the listener already knows about that. So let's say you haven't added any security, but now you want to add security to your pipeline. Do you have to go and update every single pipeline script imperatively? No. In event-based, you would simply go ahead and buy your security tool. And if that security tool already was already connected into the listener, it would then automatically execute in the correct order. And you would have to do nothing except wait for the payload of that process to return. One of the reasons why security has been an issue for our pipeline process is because of the fact that we have an imperative pipeline. And every time you want to add features or functions to it, you're having to go in and modify it manually in a very imperative way. So looking at how you're managing pipelines and move away from these imperative processes will be super critical for microservices. You want templated microservices. You want to be able to change things in one place and it replicate down through everything. If you have a new tool that you've brought in, you want a listener that's already prepared for that tool, and it says, "Hey, now you have security. I can go ahead and implement the events accordingly and pass the payload along." This is the new world of pipelines. It's not going to look the same as we had in the past. So templated. There's another tool called the Jenkins templating engine, which I really, if you're a Jenkins fan, which I really encourage you to take a look at. It has some very interesting features in it. Oh, and one last thing. The CD Foundation has a special interest group called the CD events. They are working on turning that into a proper project so that they can get a listener or a control plane built. Keep in touch with that. Start watching what's happening from the CD Foundation around events. I think it will be an important discussion over the course of 2022. Okay, now it's time for everybody to go back to school. Spend some time on learning domain-driven design. We may have thought we did that during the SOA because this stuff we started talking about domain-driven design and a shared services architecture years and years ago. We just haven't done a very good job of it. But in microservices, it's super important to start understanding what your bounded context services are going to do. And understanding a domain-driven design and how to build out those layers are going to become critical when you move into microservices. They don't have to be complicated. We just have to understand how to organize everything. So for example, this is a very simple kind of pyramid that what it might look like, where you have an infrastructure layer services and you have shared services layer, and then you have the application layer. But what do your patterns look like within your organization? And that's what domain-driven design is all about. There is online classes by Chris Richardson. He's from Cloud Foundry fame, and he has a website called microservices.io. He has some really great classes on this topic, and I recommend you take a look at it because it's going to be something that will be important. Now, you might say, why does a DevOps person or anybody in production. Why do we need to know about this? Why is that important? It's important because that's how you're going to see your world. You're going to see your world in terms of pieces and parts, and really understanding domain-driven design is going to be important for organizing it. And then we have to figure out a way to track the supply chain.
Tracy,
Yes, yes.
Sorry to interrupt you.
No
There
worries.
is a question.
Yes.
I think it's more of just asking for clarification. I'll read it out. So when we say version control becomes less critical, it's like since the code base is less for each component when compared to a monolithic, and is that why it's less critical? Correct?
It is. It's less critical because right now we rely on the version control to determine what goes into our compile process, our compile and link process for that matter, even down to pulling particular versions of code. That's it. Without a version control tool, your build process is pretty much broken. Because we're building monolithic and we rely on the version control tool to determine what's going to be put into that monolithic build. Now, and we also rely on a version control tool to take those big pieces of code and track when 2 people or 3 people are working on the same piece of code so that they can merge and understand what branch it should go on. In microservices, you're just not going to need that as much. If you have a bounded context service that's 300 lines of code that one microservice developer writes, like an API, you're not going to see that kind of practice. You're not going to see the branching and merging in the way we have done in the past. The way we've done that in the past, the branching and merging in particular, is a reflection of a monolithic style of coding. It was built and it serves monolithic coding. Version control in the future will not have as many things to do because we're going to have smaller pieces of code. So that's why I say it's going to be less critical. We'll still have it, but it won't be as critical because it's not key to building our application version. Most of our application version link step will be done at runtime via APIs. And before we did it at build, and we relied on the version control tool to figure out what we were linking into our application. So the cost of moving to microservices, I don't have an idea of what the cost is to moving to microservices. I can tell you though, the cost it hurts if you rush in and try to do it all at once, and you don't have some of these basic infrastructure pieces set up. There has been some research done by Forrester and Gartner. If your company belongs to them, there is some work that's been done on really understanding the cost of moving to services and the cost of not moving to them. So I would have to suggest that you look at some of the bigger pros that are doing heavy research on this to really give you a clean answer on that.
Tracy,
So
I think we have a question from Sanjeev. Sanjeev, I've unmuted you, or you can unmute yourself if you like.
Hey, thanks, Joshua. Hey, Tracy. So when you were talking about this version control being less critical or becoming less critical, I think one of the factors could be that when you are building a microservices, so you are building a component. So for that component, you will have only, let's say, few engineers who will be working on that component. But when you look at a monolithic application, you'll have many number of people who are working on that. And so you might have more kind of code being committed, more kind of code kind of when they're merging, there's a conflict and all. So here, I think that could also be one of the factors that you have version control less critical in the case of a microservice-based application, right?
Yes, absolutely. Thank you for that. Yes, you just have it, and it's true. If you're working in an application repository, you could have 100+ developers working on that in that repository, and you're compiling one big giant binary. In microservices, every microservice could have their own repository. It's not unlikely repos are becoming a kind of a conversation because your microservice is going to have one piece of code in it, and it's going to be pretty small.
Yeah, in fact, I remember when we used to work on writing that CMake files and all in Linux. So there you had, I think, when you're building a make file and all, the dependencies and all, when they kind of break.
So if you've ever had to write a build script like a make file or a clear make file or o make file or whatever make file you were doing, or even an and script, if you think about what you did, is you did a lot of configuration management and you did a lot of supply chain management in that process as well. And you relied heavily on what was checked into the version control tool.
Correct.
And that's kicked off everything else, right? When we got that down right, we got a clean build, we were ready to go. Sometimes it took us a while to get a clean build. Okay, so that takes us to supply chain, right? This really, I wrote a blog recently called SCM is the new SCM, software configuration, or supply chain management is the new software configuration management, and it couldn't be truer. But the ability to track which application teams are using common services will become an essential part of your DevOps process. You will need to understand that, because we need to understand the blast radius. If there is a vulnerability, we need to understand where the vulnerabilities are, who's consuming them, and being able to communicate what services are available across the enterprise. If we need to be able to have a way for the person on the 4th floor to know that the person on the 8th floor has just written a particular service that can be reused. And that level of tracking needs to be built into the pipeline in order to achieve this level of DevOps. I guess what we would call DevOps at scale. So let's just talk a bit about what we're looking at really from this component-driven release management, because that's, if we just boil it down to what the DevOps pipeline, what we have to spend our money on, we have to start thinking about everything being component-driven. So you think about microservices as being a components. And to be honest, you can have all kinds of components. If your application needed some external kind of product, that could be a component. But an infrastructure update could be a component. A database update could be a component. But microservices, if we just think about microservices, they are components and they're independently deployed. And each component has some basic information. The deployment logic. I'm the microservice developer, and I've written a Helm chart so that everybody can use that Helm chart if they want to reuse my microservice. Or they're using Ansible, or this is the connection to Spinnaker for doing it. There's going to be key value pairs for those. There's going to be secrets for those, which I forgot, didn't even put secrets up there. There's going to be the consumers of those microservices, and there's going to be the owner of the microservices. Microservices have versions. Their source code changes, you get a new version of the container. We track it based on a tag. There's going to be an inventory of the microservice across all these clusters. And most importantly, there's going to be a blast radius. Who is it impacted? Who's consuming my work? If I send it out, who am I impacting? And a collection of these microservices or components in general is now a logical application. And that logical application should have a software bill of material report, a difference report, a version report, and an inventory across cluster report. And keep in mind that when a component's updated, you update a new microservice, it creates you have a new version of your microservice. It's a release candidate, and every logical application that consumes it now has a new version. And I like to say this is kind of our new build. Even though we're building a container at the application level, everything now is logical, and it's a logical representation of what our application build looks like. So service level objectives have sort of been blown out of the water by microservices. As it says, imagine being a support person and being asked to support a microservice you know nothing about. Additional information around the DevOps pipeline is we need to understand who created the service, who do I call if it breaks. If it breaks and it's breaking in one application and it's shared, I need to tell the other applications that there's a problem. How can I see what version of that service? It's only a particular version that's breaking, and where is it running? What does the deployment metadata look like? When did it get sent out? Who sent it out? And what was the last change made to the application? Because if you're a support person and you know what the last change to that application was, then you have an idea of who maybe you should call. who should you point the finger at and say, hey, help, we have an issue. Because these are obfuscated, service level objectives have tend to be failing. You know, the incident response rates are starting to slow down, according to most people that I speak to, because they don't have this basic information. And that is bringing us to this new idea of what we call a microservice unified catalog. Now, there's several on the market. This is a new area of services, of which, full disclosure, DeployHub is a part of. And Ortelius is about 80% of the DeployHub code. And what a catalog does is it tracks what pipeline you're using, your ownership, who created the microservice, the deployment logic, what are you using to do the deployments, what are the key value pairs, where are the secrets stored, not exposing the secrets, but where, you know, give me a URL to them, what's the inventory look like, the version, and the logical, and what logical applications are that are using it. There's two that are incubating at the Linux Foundation. Ortelius is one. It's incubating through the CD Foundation, and Backstage is incubating through the CNCF. Backstage actually is probably going to be looking at graduating pretty soon. It's pretty popular. So the use of these microservice catalogs are growing, and for all the reasons I just described. So Ortelius is a catalog, a microservice catalog. The way it's different from projects like Backstage is that it actually does the versioning of the services as associated to the logical application. So it can track the blast radius and the inventory across the clusters. It is an incubating project. It started incubating last year. And the core mission is to really simplify the adoption of microservices. And we do have an amazing group of enthusiasts from all over the planet, from South Africa to Pakistan to Nairobi to Chile, and of course the US and Europe. So we're pretty excited about the team. Let's just think about what it looks like as part of the CD pipeline. Where do you drop this in? So this is a really scaled back version of a CD pipeline, but I'm just going to walk through it. So at the point when what we used to do during our builds is we would do a check-in, and we waited our time, and then we would do a compile. So the compile was triggered by the check-in. Updating the catalog is done the same way. As soon as a new container image has been registered to Quay or wherever you're managing it, it wakes up Ortelius, and Ortelius then goes and grabs the SHA, gets the tag, creates a new version of it, and looks through the database for every application that used it. And it knows that because the application consumers use Ortelius to package their logical application. And at that point in time, it can tell, it creates a new version of that application, and it can show a difference report from the last version of the application. On the right-hand side, when the container gets pushed out, Ortelius has woke up and it says, go push the container out based on the deployment logic that was assigned using Helm, using whatever the component's been assigned to, and then it tracks where it's been deployed across all the clusters. So we have on the left side, we have it registered with the application version tracking, and on the right side, we have the inventory tracking. There's a full set of APIs that DeployHub has written around this that you can also use to create your own pieces and parts to the process. And what you get are some, yes.
Sorry, Tracy. There is a question here. Yasser, feel free to chime in and unmute yourself. I'll read out the question. It says, no dev team is accepting to dismantle their app built for years into small chunks unless there is a big purpose, especially enterprise resource planning apps.
I would guess that to be true. I think that we're going to see monolithic hang on for as long as possible. But as we really start building new applications, and many companies will start decomposing their existing monolith as they see the benefits. But as we begin building new applications, they will most likely be built on a microservice architecture. And that's really going to depend on the direction of the architect at the enterprise, right? While no, developers hate the idea of breaking up everything, and they probably may not do that initially, as they start building new things, I'm guessing they're going to be building them on microservices. But there's no doubt monolithic will hang around for quite some time. So everything that you've done in the past will continue working without fear. But as application teams start looking at building out new services, in particular ones that machine learning and artificial intelligence, the whole AI, they really are needing the ability to do this auto scaling. So let me just take a side step here, and I don't know what the time looks like, but I'm going to tell the story anyway. So first time I ever saw microservices actually work, I went to a local sort of software developer meetup and a local company that was building a microservice architecture around the company's called OpenEye, and they work with pharmaceutical companies to track a DNA compound to see if it's been patented. So think about aspirin, it has a particular look to it, and they do pattern matching on finding it. Well, this process in monolithic terms could take a long time, could take weeks to figure this stuff out. And what they created was a architecture around containers where they would go out and they would spin up to do the pattern matching. They started at like 15 GPUs, and it went to like 15,000 in a few seconds, and they brought the answer back instantly. And my head exploded. I asked them to do it again because I had to see it happen. Because if we think about what that looks like in a monolithic, we could do that by containerizing a monolith, but they didn't do that. They only containerized that particular function. And that function spun up super, super fast, super, super efficiently, went out, did its job, and came back. That is the benefit of having a bounded context function like a microservice running in a Kubernetes or an AWS orchestrated container environment. And it's my belief that most companies are going to go to that world. So tracking applications, here's a sample of a difference report and an SBOM report based on that. And if I have time, I'll quickly go do a quick demo. What's the time we got?
I believe we have about 9 minutes. Josh, is that right?
Okay.
We'll say 10 minutes, and you can run a couple of minutes over because we started a couple minutes late. So,
all right.
Yeah.
So I am going to, first, I'm going to encourage any of you who are interested in being part of these discussions to, look at the CD Foundation at some of these SIG groups. I would encourage you to get involved in the events group. And certainly if you're interested in helping us solve this cataloging problem around microservices, the Ortelius team would love to have you. Here's my info, but I'll come back to that, but I'm going to just quickly be brave and jump out of here. And I would show you Ortelius, but they're doing a bunch of new, I only have the dev environment updated here, and I don't want to show you something in a dev environment at this point. I'm only going to, it says DeployHub up here, but I'm only going to show you the Ortelius features. I'm not going to show you any of the what we call the enterprise features. So let's just think about this story in terms of domains. We talked about domains, and we talked about kind of an online store. In a domain-driven design, the way Ortelius is set up is to take your structure of your domain-driven design and build it into a catalog. In this case, this online store company, it has a hipster store, which is the product we're creating. It has the purchase processing and the store services. So these are catalog domains, and this is a product domain. Let me make sure I have this up big so you guys can all see it clean. Okay, so inside the purchase processing domain, we have currency, checkout, cart, payment, and shipping. This is where a microservice developer would register their microservice so that applications then can consume it. Now, if we look at the hipster store, what we do is we create a base version of the hipster store based on something that the application teams are familiar with, and that is creating a package. And if you see over here, I got to move all the people so I can see over here. We have the online store company, and we have those domains that we were looking at. Here's the purchase processing, and we can see the cart service, and there's many versions of the cart service. We got 2 different versions of the cart service that's being created. Now, what happens is if we look at the cart service at the component level, we can see that there are, let's see, cart service. There's a base version of cart service, and there's a GC6 and a GAF7 version of the cart service. These are the base version of the cart service. You can see up here it says component base version. This is when the developer first registered it. But over time, every time they went and updated the container registry, Ortelius creates new versions of it. This is the version that the hipster store was using, and there is, I'm gonna have to get rid of that. Okay. This shows that the base version of the hipster store used it, and the base version of the hipster store 4th of July sale used it. Now, if we continue on its little journey here and we look at the GAF version, we can see that that created new versions of the hipster store Labor Day sale. Now we have a 1.2.10 and a 1.2.9.1. So it actually branched it for the team. So what it's doing over time is it's tracking the differences. And that way, if you're the application team and you were running the hipster store and you don't know that something changed, we didn't create the cart service. The cart service just got updated. I can take a look at at my blast radius, and I can take a look at my difference report, and I can see that it was the cart service that got updated. Now I'll be kind of brave here, and I'll go over to the Ortelius dev site, and I'll show you what we've been adding to it, what the team has been adding to it. Right, so if we take a look at the components, there's some new stuff that they have added, which is super helpful in really understanding the life of a particular object. So if we look at the cart service from here, this data, you can see that we've added some interesting pieces. Not only do we keep track of the service ownership, which is empty in this case, but if it was a real world, it would not be. But we've added the README. We've added the Swagger information, so you can see those pieces. We've also added CVEs because it's kind of important to understand what those vulnerabilities could be based on that. And we've added the license consumption, the key value pairs, and we've added licensing. So we're starting to grow the data that we store on these objects. You know, if we think about what Ortelius really is, it's a data hoarding platform for deployment information, so that when we do move to a full microservice environment, we have things like an audit trail, and we can control those pieces and parts. So that is what we are up to. I'm going to go ahead and I'm going to jump back to here and end with a thank you. And I would like to take questions because I suspect that there are folks out there who have some interesting points of view that I would very much like to hear. Tell me where I'm wrong, because that's what meetups are all about.
There is a question from John in the Q&A box. John, feel free to unmute and chime in if you would like. It says, what does testing look like in the new microservice world? What changes compared to monolith designed containers and services?
So probably the biggest, let me see if there's an image that I can use. Not really in what I have. The biggest change is going to be this. So what should happen in your pipeline process is that when the shipping service gets updated, we need to now kick off 3 different testing workflows, because the application teams, they need to have an opportunity to take a look at what that shipping service may have done to them. More than likely nothing, and automated testing can solve the problem, and it still can get pushed across pretty quickly. But now we need to have a DevOps pipeline that has there needs to be a way to have a quorum. So if you have a shipping service and it impacts not just 3, but let's say 10 or 15 applications, and 5 of them say, yes, it's good to go, maybe we should let it rip. The other thing that's going to change is understanding risk value of microservices. Something I'm really pushing the open source community to take a look at and how we can help manage that. we should be able to, from a microservice risk value, determine what pipeline it needs to go through and how much testing that needs to be done. So let's say we have the candy store is releasing its front end service. It should be able to go through as quickly as possible. So maybe a smaller pipeline process should be selected for it automatically. But if the shipping service is out there and it impacts 3 or 10 or 15 applications, and the last 2 times we deployed it, it caused problems, maybe we need to now have a new pipeline process for it based on its risk value. So we need to start thinking about, I talked earlier about pipelines being event-based. If they're event-based, we could then decide which pipeline process we wanted a microservice to go through. And that microservice might go through a pipeline process that has a more stringent testing workflow to it. That is going to be the beauty of being able to track and control microservices in this way, is that we will then be able to continually move fast, generate or assign a pipeline based on its risk value, and allow the testing teams to do what they need to do to the pieces that have a higher impact, and not be so focused on the ones that have low impact, and the application coding team may have already done the level of testing that needs to be done. So we can start thinking about testing in terms of testing components as opposed to testing an entire application, which means that it should be able to be faster. But when it comes to the blast radius, there's going to be some pain involved in that. And if we can automate the pipelines to say, I've got one microservice coming through the pipeline, it impacts 10 applications. Let's re-execute all the testing for all 10 applications before we take it back down and deploy it out to all end targets. So that's how I think it's going to start looking.
And there is a part 2 to this question. Are there cases where moving in the microservice direction might not be the right choice? Absolutely.
I think that I've seen some really big, fat monolithic applications out there. And as somebody else spoke before, it says maybe, dev teams aren't that excited about pulling out their applications. And if there's not a real need, let's look at it this way. If the application isn't necessarily needing to scale quickly, if you don't necessarily have problems with fault tolerance, and you're not trying to build out communication between multiple applications, maybe you just keep it where you are. However, if your application is looking at the ability, if you it's slow in some places, you're having sluggish issues, you're struggling with communicating with other applications, then I think what we have to do is stop what we're doing, take a step back, and look at those applications in terms of that domain-driven design. That's why I keep pushing that. Understanding DDD is going to be super, super important in making these decisions. If you can look at those applications and you look at them and you realize that in your enterprise set of applications, you have 5 major applications, and all 5 of them have their own, how to get customer info, their own login, their own logging routines that are supposed to do the same things, and you're struggling with that, then looking at a microservice architecture and building out microservice applications is a extremely productive thing to do. And then you can make a decision if it works for you. So I think you have to really understand what domain-driven design can bring to the table. You have to understand why microservices are important from a fault-tolerant and auto-scaling practice, and understand if your applications are going to fit. We are just the open source team. We're just starting to break Ortelius into microservices. There was a big discussion of why we would want to do that. And there were areas of the product that we saw were slow. And we thought if we could spin this function up to more GPUs, then that's going to be really helpful, especially when we build these graphs. But even more helpful is the ability for one contributor to work in Go and another work in Python. And another one work in JavaScript and be completely independent and not stepping on each other. So there were a lot of benefits that we looked at in terms of moving to a microservice architecture, and we drug our feet before we said we were going to do it fully. And I think that at this point, we're going to embrace it completely.
Cool, Tracy, we're going to keep going in this theme of meetups and back and forth. Are you okay on time?
I'm totally okay. I do have a hard stop at 12:15, but I've got another 10 minutes easily.
Great. Well, let's keep going.
We have a question from Venkat, and Venkat, your hand's up, so feel free to ask and yourself.
Thank you. Tracy, first of all, thank you so much for the enlightening presentation.
Thank you.
And certainly, it was quite in detail, specifically on the subject, whatever you talked just now. Having said, what are your thoughts in terms of the top key issues around microservices management?
Well, I think it's the tracking of them. I think it's the sprawl and drift that gets people into trouble. So we had one customer who had 17 different test environments, and they could not, from just looking at those test environments, they could not tell which version of a microservice was being tested by which customer. That's a problem, right? That is what people feel they say it's too complex, because what we're trying to do is a link step at runtime. How do you know what version you're linking at runtime if you don't have some visibility? Now there's kind of two tracks of thinking on this. One is observability, and I think observability is critical. I'm not saying it's not at all. But observability is looking at a single cluster and looking at the transactions to try to figure out what the problem is. Visibility, what these catalog tools are doing, is providing that information before you ever deploy. So understanding what your cluster is going to look like before you push it out there, and understanding the sprawl and drift and getting control of it, I think is one of the main reasons why these catalogs are becoming important. The other thing I think that's going to be a challenge that we should be looking at and spending money on is the DevOps pipeline, and how to make it more declarative and not so imperative. Because that's the only way we're going to be able to cleanly track what's moving across the pipeline and who's impacted by it. And for lack of better naming, what is our corporate supply chain? How is that supply chain changing? Is all of that still safe, or did something bad get added to it? And who's being impacted? And who do we need to notify if there is an issue? And an issue could be something as bad as a SolarWinds problem, or as simple as a bug that's really annoying to the end user. There's a question about what about latency between MSs? I'm sorry, I don't know what MSs are. Can you tell me what an MSs is?
I think it might be microservices. There might be.
Oh, what about latency? That is all about observability. So that is not something that your catalog can do. However, the catalog, if you are thinking about the blast radius, everything's working good right now. There's latency between two services. What changed? The catalog and the DevOps pipeline needs to be able to tell everybody what changed that might have caused that latency. But observability tools are going to give you much better insights in terms of the latency issues, because you're going to be able to watch them. Things like Prometheus are going to continue to be really important.
Awesome. So Sanjeev, did you have another question?
Thanks. I had one more question. Thank you for talking about that observability and visibility part. So let's say if you want to see some kind of an API lifecycle management kind of a thing, that also is there in this thing, Ortelius?
We can manage APIs, but remember, APIs are really something that you're going to be linking. Unlike a microservices that's going to be running independently. Now, APIs and microservices are the same thing. So once the API grows to be a microservice and it's in its container, then yes, we're managing it. Yeah, any of these tools would. Backstage would manage it, because you would have to register it. So part of the process is registering that API or the microservice.
Yeah, so when we say blast radius, so that will include even your traceability part also, the visibility and observability, I think all together, because in which kind of microservice, when you are deploying to which kind of other service it is impacting, in which container it is impacting, all that. I think this will be a kind of inclusive of all these things in blast radius.
Yes.
Okay.
Yes. Your blast radius is going to say for any one component, who is it impacting? And then from the application level, you can see where it's been installed.
Right. So
right.
Another point was like, this is something could be for the future. So let's say if people have written monolithic code, let's say, and they are not now part of some organization where it has been deployed. So you get a new person who has to look at that code, which could be some kind of a, not even modular code, it could be some spaghetti code also. And so they find it difficult to kind of manage that. Now they are kind of given the task of moving it into a microservice-based application. So do we have, did anyone kind of made an attempt to build a tool? Let's say you push this code directly into that tool and it kind of give you some at high level domain-driven kind of a thing. You kind of segregate that based on the domain. Did anyone try to attempt, or we are waiting, let's say in the future, we have a better thing in AI and ML space, which can kind of take this code, someone's existing code, and try to break it into a domain-driven development model.
And that's the reason why we added in Ortelius those domain structures, so that it makes it easy to find things, right? How do you communicate and collaborate with everybody if you're writing these awesome services, if you don't have a way to advertise them?
Yeah, but let's say if you have a monolithic based application code, is there any if someone has built or made an attempt where you take that code and push into your tool and it kind of generate, right?
No, we have not. We have not taken on the task of looking at a monolith, and you might be able to do some of that from the build. I know that in a previous company, a company I still have ownership in, we specialized in the build process, and we were very careful about what went into the build. And when I say it wasn't the CD pipeline, it was really how to manage the libraries moving into your application. And there's probably something to be said about that we could potentially take the libraries, and if we could figure out a way to look at their naming and understand what domains that they should go in, because even though I say we should learn about domain-driven design, for the most part, when you look at the components of a monolithic, oftentimes they're given names based on what they do, which is potentially part of the domain structure. So I think we could do some decomposing at the build level to try to figure that out, but that is not something that's part of the Ortelius roadmap at this point.
Okay.
Thanks, Tracy.
I have to jump in there. Thank you, Sanjeev, for the question. That's great. And Samia, I will let you close it out.
Yeah, thank you so much, Tracy. This has been a wonderful hour, so much learning, and there's so much information to absorb here. And thank you, everybody, for staying with us. So real quick, we are cloud native at scale. We're a San Francisco-based meetup focused on CNCF projects. Josh has posted a link for our next meetup, so we will all see you there. And once again, thank you, everyone, and thanks, Tracy.
Thank you. It was a pleasure. I enjoyed it.
Thank you, Tracy. We'll be in touch.
Okay.
All right. Take care now. Bye.
Right. Bye-bye.
Bye, everyone. Thanks.
Thank you.
Thank you, Samia.
Bye, everyone.
Goodbye.
See ya. Bye.
Thanks, Josh.
We'll talk soon.
Talk soon.
All right. Take care.